Hello everyone, welcome to the lecture. Myself B Devananda Rao, working as Associate Professor in the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is NFA to DFA conversion using subset construction. Given example, given NFA problem, NFA example, now we need to convert this given NFA to equivalent to DFA by using subset construction. NFA is a phi tuple Q sigma delta Q naught and F. NFA is a phi tuple Q sigma delta Q naught F. Here Q is set of states Q naught, Q1, Q2. Three states are given. Sigma input alphabet is 0, 1. Delta is a transition function. Q naught is the initial state. This is the initial state. F is set of final state. Q2 is the final state. Now we need to convert this NFA into equivalent to DFA by using subset construction. See, every DFA is by default NFA. Every DFA is NFA. Every DFA is NFA, but not every NFA is not DFA. Every DFA is NFA, but not vice versa. But not every NFA is DFA. Now, by using subset construction, we can convert this given NFA to DFA. First, we need to construct the transition table for given NFA. Of NFA, transition table of NFA. Columns representing input alphabet 0, 1, given input alphabet is 0 and 1. States, rows representing the states Q0, Q1, Q2. Q0 is the initial state, Q2 is the final state. Then we need to fill the table. Q0 on 0 going to Q0 for this 0 and as well as going to Q1. So that Q0 for input 0, we are going to Q0 as well as Q1, set of two states Q0, Q1. Then Q0 on 1, Q0 on 1 going to Q0 on 1 going to Q0, Q1 on 0 going to Q2, Q1 on 0 going to Q2, Q1 on 0 going to Q2. Q1 on 1, there is no transition. Transition is not defined because in NFA, no need to define the transition for every input symbol. But in DFA, you need to define the transition for every state for every input symbol. Next, Q2, there is no transition for input 0 and there is no transition for input 1. So that pi, that is null set. If there is no transition for a given input symbol, pi is written. Then this NFA having three states. The definition of NFA is Q sigma delta Q naught and F. Here the Q is set of states, that is Q naught, Q1, Q2. The equivalent DFA can have 2 power n states. In DFA, equivalent to DFA can have 2 power n states. Equivalent to DFA can have 2 power n states. Here in the given NFA, 3 states are given Q0, Q1, Q2. The equivalent DFA can have 2 power 3 states, that is 8 states. Then transition table for DFA. Input alphabet sigma, same is input alphabet for DFA also 0, 1. Then 8 states, 2 power 3, 8 states. So the subsets, the states of DFA is set of subsets of NFA. States of DFA is set of subsets of NFA, subsets of states of NFA. Here the states of DFA is set of subsets of states of NFA. Here the states are Q0, Q1, Q2. The subset for this set of states is pi Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, Q0, Q1, Q2. 1, 2, 3, 4, 5, 6, 7, 8 states. So, total 8 states in equivalent to DFA. The initial state in the given NFA is Q0. So, that in equivalent DFA also same initial state Q0. Final state in NFA is Q2. So, that in equivalent DFA the sets whichever set having state Q2, that is the final state. Here Q2 is the final state. The set containing a state Q2 is the final state. Here Q0, Q2. This is also a set containing Q2. Q1, Q2 is also a final state. Then Q0, Q1, Q2 is also a final state. But then we need to fill the table. Q pi on 0, there is pi means dead state. There is no transition, dead state, pi only. For input 1 also pi. Then Q0 on 0. So, by seeing this table, we can fill this equivalent to DFA table. Q0 on 0 going to Q0, Q1. Q0, Q1. Then Q0 on 1 going to Q0 on 1 going to Q0. Next Q1. Q1 on 0 going to Q2. Q1 on 1 null, pi, null set. Q2 on 0 null set. Q2 on 1 null set. Next Q0, Q1. See, take union of these two. Union of these two. Q0, Q1 on 0. Take union of these two. Q0, Q1 on 0 going to Q0, Q1. Take union of these two. Q0, Q1, Q2. Next Q0, Q1 on 1. Take union of these two. That is Q2, Q0 and pi. So, only Q0 only. Q0, Q1, that is Q0, Q1, Q2 and Q0, Q1 on 1, that is 0, Q0. Next Q0, Q2, Q0, Q2, taking these two, union of these two, this and this. Q0, Q2, Q0, Q2 on 0, taking union of these two, we will get Q0, Q1. Like that Q0, Q2 on 1, take union of these two, that is Q0. Next Q1, Q2, take union of these two. Q1, Q2 on 0, Q2, Q1, Q2 on 1, pi, null set. Next Q0, Q1, Q2, Q0, Q1, Q2 on 0, take union of these 3. So, Q0, Q1, Q2. Q0, Q1, Q2 on 1, take union of these 3, we will get Q0 only. So, this is the transition table of equivalent to DFA. Now, we need to find the accessing states from the starting state. So, starting state of NFA is same as starting state of DFA. So, from this starting state, we need to find what are the states accessible from initial state Q0. So, Q0 on 0 going to Q0, Q1. So, that from Q0 on 0 going to Q0, Q1. So, Q0, Q1 is the accessible state. So, Q0, Q1 is the accessible state. Then, Q0 is also by default accessible because initial state. Q0 is accessible state. Q0 on 0 going to Q0 Q1, that is Q0 Q1 is accessible state. Q0 on 1 going to Q0, that is already accessible state. Next, Q0 Q1 on 0 going to Q0 Q1 Q2. So that Q0 Q1 Q2 is the accessible state. This Q0 Q1 Q2 is the accessible state. Then Q0 Q1 on 1 going to Q0. Q0 is already accessible state. Next, Q0 Q1 Q2 on 0 going to Q0 Q1 Q2 same state, so that is accessible. Q0 Q1 Q2 on 1 going to Q0, that is also already accessible state. So that among 8 states, only 3 states are accessible. Only 3 states are accessible. 3 states are accessible. Then now we need to construct equivalent DFA transition diagram. Starting with initial state Q0. Q0 is the initial state. Q0 on 0 going to Q0 Q1. Next, Q0 on 1 going to Q0. Next, Q0 Q1, Q0 Q1 on 0 going to Q0 Q1 Q2. Next, Q0 Q1 on 1 going to Q0. Next, Q0 Q1 Q2 on 0, Q0 Q1 Q2 on 0, same self state. Next, Q0 Q1 Q2, Q0 Q1 Q2 on 1 going to Q0. So, final state, wherever Q2 is there in the diagram, that is the final state. Here Q2 is there, so that this is the final state. So that we need to draw 2 circuits. Final states are represented with 2 circuits. This is the equivalent transition diagram for the given NFA. See, NFA, this is the NFA for the language containing strings ending with 0 0. Strings ending with 0 0. The equivalent DFA also will recognize the strings ending with 0 0. See, Q0 on 0 going to Q0 Q1, Q0 Q1 on 0 going to Q2, that is Q0 Q1 Q2, that is a single state. From Q0 Q1 Q2 for input 0 going to same state. So, any string end with 0 0, any string end with 0 0, those strings will be recognized by this DFA as well as NFA. So, that given NFA and DFA both are equivalent. Another example for conversion of NFA to DFA. This is given NFA. As usual, NFA 5 tuple Q sigma delta Q0 and F. Q0 is the initial state, F is the set of final state. Here in the given NFA, Q3 is the final state, Q0 is the initial state. So, transition table for this NFA, same input symbol 0, 1, states Q0, Q1, Q2, Q3. Q3 is the final state, Q0 is the initial state, Q0 on 0, Q0, Q1. So, from Q0 for input 0 going to Q0 as well as going to Q1. Next, Q0 on 1 going to Q0. Next, Q1 on 0 going to Q2, Q1 on 1 going to Q1. Next, Q2 on 0 going to Q3, Q2 on 1 going to Q3, same state. Next, Q3 on 0, no transition, that is pi, Q3 on 1 going to Q2. So, this is the transition table for given NFA. Now, we need to construct equivalent to DFA by using subset construction. So here total 4 states are given in NFA. Q having 4 states. Set of states in NFA is 4 states. In equivalent to DFA, can have 2 power 4, that is 16 states. 16 states, but no need to find all 16 states. We will consider only accessible states from initial state Q0. Now construct the table. Columns are representing input alphabet, rows are representing states. Initial state of NFA is Q0, so that equivalent to DFA also having same initial state. Any NFA DFA can have only one initial state, and final states are maybe more than one. Q0 is the initial state. See, Q0 on 0 going to Q0 Q1, Q0 Q1. So now Q0 Q1 is the accessible state, Q0 is initial state. So Q0 on 1 going to Q0. Q0 is already initial state, that is accessible state. Now we consider accessible state, new accessible state. Q0 is already accessible state, initial state, so that new accessible state is Q0 Q1. Take Q0 and Q1 as a single state, set of states. Even it is 2 states, Q0 Q1, we will consider it as one single state. Next, Q0 Q1 on 0, Q0 Q1 on 0, take union of these two, we will get Q0 Q1 Q2, Q0 Q1 Q2. So Q0 Q1 Q2 is a state that is accessible from initial state. Then Q0 Q1 on 1, Q0 Q1 on 1, take union of these two, we will get Q0 Q1. Next, Q0 is initial state, Q0 Q1 initial state, take Q0 Q1 Q2 is accessible state, so that consider that Q0 Q1 Q2 as a state, Q0 Q1 Q2. This is accessible. Q0 Q1 Q2 on 0, Q0 Q1 Q2 on 0, take union of these three, Q0 Q1 Q2, Q0 Q1 Q2 Q3. On 1, consider these three, union of these three, Q0 Q1 Q3, Q0 Q1 Q3. So Q0 Q1 Q3 is accessible, Q0 Q1 Q3 is accessible, Q0 Q1 is accessible. This is already processed, Q0 Q1. Next, consider this one, Q0 Q1 Q2 Q3, Q0 Q1 Q2 Q3. So Q0 Q1 Q2 Q3 on 0, take union of these 4, will get Q0 Q1 Q2 Q3. On 1, take union of this 4, Q0 Q1 Q2 Q3. So already this is accessible state. Next, take this Q0 Q1 Q3, already this is not processed before, so that consider this Q0 Q1 Q3 on 0, Q0 Q1 Q3, Q0 Q1 Q3, take union of these three, Q0 Q1 Q3. So if you take union, we will get Q0 Q1 Q2. Next, Q0 Q1 Q3 on 1, take union of these three, Q0 Q1 Q2. So this is already processed. Next, Q0 Q1 Q2, Q0 Q1 Q2 already processed, accessible and processed, Q0 Q1 Q2 already processed. That's all, no new state is created. So that's all, total 5 states, 5 states are accessible states. Now we will draw the transition diagram for NFA, equivalent NFA. Initial state is Q0, starting state Q0, Q0 on 0 going to Q0 Q1, Q0 on 0 going to Q0 Q1, on 1 going to Q0. Next Q0 Q1 on 0 going to Q0 Q1 Q2. Q0 Q1 on 1 going to Q0 Q1 self loop. Next Q0 Q1 Q2 on 0 going to Q0 Q1 Q2 Q3. Q0 Q1 Q2 on 0 going to Q0 Q1 Q2 Q3, on 1 going to Q0 Q1 Q3. Q0 Q1 Q3 on 1. Next Q0 Q1 Q2 Q3 on 0 going to self state, on 1 also same state, self state 0 comma 1. Next Q0 Q1 Q3 on 0 going to Q0 Q1 Q2, this is the state 0. Next Q0 Q1 Q3 on 1 also same state Q0 Q1 Q2, so that 0 comma 1. For 0 and or 1 we are going to Q0 Q1 Q2 from Q0 Q1 Q3. So now we need to find the final states. In the given NFA, Q3 is the final state, so that wherever Q3 is there, that is the final state. Here Q3 is there, so that this is the final state. Here this is also a final state. So Q0 is the initial state. So if NFA having n states, the DFA can have 2 power n states. So in the given NFA, 4 states are given, so that equivalent to DFA can have maximum 2 power n state, that is 16 states, but we will not consider all 16 states, only accessible states we will consider, so that accessible states are only 5 states in the given example. Thank you.